Tracer ammunition are bullets, a cannon caliber projectiles that are built with a small pyrotechnic charge in the base. Ignited by the burning powder, the pyrotechnic composition burns very brightly, making the projectile trajectory visible to the naked eye during daylight, and very bright during nighttime firing. This enables the shooter to make aiming corrections without observing the impact of the rounds fired and without using the sights of the weapon. When used, tracers are usually loaded as every fifth round in machine gun belts, referred to as 4-to-1 tracer. Platoon and squad leaders will load some tracer rounds in the magazine or even use solely tracers to mark targets for the soldiers to fire on. Tracers are also sometimes placed 2 or 3 rounds from the bottom of magazines to alert the shooter that the weapon is almost empty. During World War II, aircraft with fixed machine guns or cannons mounted would sometimes have a series of tracer rounds added near the end of the ammunition belts, to alert the pilot that he was almost out of ammunition. More often, however, the entire magazine was loaded 4-to-1 on both fixed offensive and flexible defensive guns. To help mitigate the difficulties of aerial gunnery, tracers were very common on most World War II aircraft, with the exception of night fighters, which needed to be able to attack and shoot down the enemy before they realized they were under attack, and without betraying its own location to the enemy defensive gunners. The United States relied heavily on tracer ammunition for the defensive Browning M250 caliber machine guns on the heavy bombers such as the B-24 Liberator, but they found that during deflection shooting, gunners who tried to aim using the tracers rather than the sights ended up not leading the enemy aircraft enough and missing, because of an optical illusion that made it appear that the tracers were striking the aircraft, when in reality they were passing significantly behind it. This proved true of fixed forward-firing guns as well. In some cases, gunners were ordered not to use tracer ammunition at all, but in the end, with greater emphasis during training on using the sights and not trusting the tracers, the problem was solved to a large degree. Tracer rounds can also have a mild incendiary effect, and can ignite flammable substances on contact, provided the tracer compound has started burning and is still burning on impact. History. Before the development of tracers, gunners relied on seeing the bullet impacts to adjust their aim. However, these were not always visible, especially as the effective range of ammunition increased dramatically during the later half of the 19th century, meaning the bullets could impact a mile or more away in long-range area fire. In the early 20th century, ammunition designers developed spotlight bullets, which would create a flash of smoke puff on impact to increase the visibility. However, these projectiles were deemed in violation of the Hague Convention's prohibition of exploding bullets. Quote, "This strategy was also useless when firing at aircraft, as there was nothing for the projectiles to impact on if they missed the target." Designers also developed bullets that would trail white smoke. However, these designs required an excessive amount of mass loss to generate a satisfactory trail. The loss of mass en route to the target severely affected the bullet's ballistics. The United Kingdom was the first to develop and introduce a tracer round, a version of the 303 cartridge, in 1915. The United States introduced a .30-06 tracer in 1917. Prior to adopting red bullet tips for tracers, American tracers were identified by blackened cartridge cases. Tracers proved useful as a countermeasure against Zeppelins used by Germany during World War I. The airships were used for reconnaissance, surveillance and bombing operations. Normal bullets merely had the effect of causing a slow leak, but traces could ignite the hydrogen gas bags, and bring down the airship quickly. In World War II, U.S. naval and marine aircrew were issued tracer rounds with the sidearms for emergency signaling use, as well as defense. Construction. A tracer projectile is constructed with a hollow base filled with a pyrotechnic flare material, often made of phosphorus or magnesium or other bright-burning chemicals. In NATO standard ammunition, this is usually a mixture of strontium compounds and a metal fuel such as magnesium. This yields a bright red light. Russian and Chinese tracer ammunition generates green light using barium salts. Some modern designs use compositions that produce little to no visible light and radiate mainly in infrared, being visible only on night vision equipment. Types. There are three types of tracers: bright tracer, subdued tracer, and dim tracer. Bright tracers of the standard type, which start burning immediately after exiting the muzzle. A disadvantage of bright tracers is that they give away the shooter's location to the enemy. As a military adage puts it, tracers work both ways. Bright tracers can also overwhelm night vision devices, rendering them useless. Subdued tracers burn at full brightness after 100 or more yards to avoid giving away the gunner's position. Dim tracers burn very dimly but are clearly visible through night vision equipment. The M196 tracer cartridge is a training round for 5.56 mm by 45 mm NATO weapons. It has a red tip and is designed to trace out to 500 yards. The M856 tracer cartridge is used in the M16A2, 3/4, M4 series, and M249 weapons. This round is designed to trace out to 875 yards and has a red tip. It is not to be used in the M16A1 except under emergency conditions and at ranges of less than 90 meters, because the M16A1's rifling twist is not sufficient to stabilize the projectile. The M16A2 rifle has a rifling twist of 1 in 7 inches to stabilize the M856 tracer rounds. The M25 is an orange-tipped 30-06 Springfield tracer cartridge consisting of a 145 GR bullet with 50 grains of IMR 4895 powder. The tracer compound contains composition R321, which is 16% polyvinyl chloride, 26% magnesium powder, 52% strontium nitrate. The M62 is an orange-tipped 7.62 times 51 mm NATO tracer consisting of a 142 GR bullet with 46 grains of WC 846 powder. The tracer compound contains composition R284, which is 17% polyvinyl chloride, 28% magnesium powder, and 55% strontium nitrate. The M276 is a violet-tipped 7.62 times 51 mm NATO dim tracer that uses composition R440, which is barium peroxide, strontium peroxide, calcium resonate, for example calcium abietate, and magnesium carbonate. Tracer compositions can also emit primarily in infrared for use with night vision devices. An example composition is boron, potassium perchlorate, sodium salicylate, iron carbonate to magnesium carbonate, and binder. Many variants exist. Other applications. Tracers can also serve to direct fire at a given target, because it is visible to other combatants. The disadvantage is that they betray the gunner's position. The tracer path leads back to its source. To make it more difficult for an enemy to do this, most modern tracers have a delay element, which results in the trace becoming visible some distance from the muzzle. Its lethality is similar to conventional ammunition. However, the mass loss and the burning aspects can make the consequences of the impact slightly different. Besides guiding the shooter's direction of fire, tracer rounds can also be loaded at the end of a magazine to alert the shooter that the magazine is almost empty. This is particularly useful in weapons that do not lock the bolt back when empty. During World War II, the Soviet Air Force also used this practice for aircraft machine guns. One disadvantage in this practice is that the enemy is alerted that the pilot or shooter is low on ammunition and possibly vulnerable. For ground forces, this generally offers no tactical advantage to the enemy, since a soldier with a crew-served weapon such as a machine gun who is out of ammunition is supposed to alert his team that he is dry and rely on their cover fire while he reloads the machine gun. Thus, an enemy must risk exposing himself in order to attack the reloading soldier. Modern jet fighters rely on radar or laser-guided missiles to track and destroy enemy planes or other targets, rather than the plane's autocannon, which is just an ancillary weapon. This and the fact that the gun sight is radar-directed makes the use of traces in the rotary cannons unnecessary on 2015-era jet fighters. As long as the pilot can put the pipper in the HUD onto the target, he can be assured that the burst will be on target. Since the radar and computers automatically compute range, closing rate, deflection, lateral accelerations, even weather conditions. Thus, one of the primary reasons for using traces on aircraft in the first place, uncertainty over where the bullets will end up in relation to the target, is deleted. Another use from the tracer is in tank hull machine guns, where the user cannot see where he is aiming. Thus, he has to rely on tracer bullets to guide him. Safety restrictions. In the UK, usage of tracer rounds is restricted on National Rifle Association of the United Kingdom operated ranges, due to an increased risk of fire. Unauthorized use is punished at the discretion of the acting range officer. Use of traces is usually only authorized during military training. In July 2009, a large fire was started by tracer ammunition near Marseille, France, an area where shrub vegetation is very dry and flammable in the summer, and where normally this kind of ammunition should not be used. On February 24, 2013, a fire was started at DFW Gun Club in Dallas, Texas by the use of a tracer round inside the facility.